In section 5.6, we are factoring trinomials. So factoring trinomials of the form ax squared plus bx plus c. In the previous section, we used factoring by grouping to factor 4-term polynomials. In this section, we present techniques for factoring trinomials. Since x minus 2 times x plus 5 equals x squared plus 3x minus 10, then we say that x minus 2 times x plus 5 is the factored form of x squared plus 3x minus 10. Most students cringe when the word factoring is mentioned. Luckily, there are many ways to factor trinomials. The trick is to find one that works for you. I am going to personally use the same method throughout the entire course, and it's called the Berry method. If you're not a fan of this method, you can look up other methods or come and ask me to show you other methods. So the Berry method, the first step is to factor out the GCF if needed. You will find the product of A and C, so the leading coefficient and the constant. You'll write out the factors of that product. You want to find two numbers from that list that add up to B, which is the middle coefficient. Group the product of the leading coefficient and x with the two factors found in step 4, and divide out any common factors of each binomial. So let's go ahead and try this out. We have x squared plus 10x plus 16. So I'm going to write out A, B, and C just to make it a little bit easier. But first we want to see, is there any greatest common factors that we can pull out? We can't pull out any variables because 16 doesn't have any. And the coefficients are 1, 10, and 16, so the greatest common factor is just 1, and we don't need to pull that out. So my A is 1, my B is 10, and my C is 16. We want to do A times C. Well, A times C is 1 times 16, which is 16. Because we got a positive number, we could either multiply positive 1 times positive 16, so two positive numbers, or I could have potentially multiplied negative 1 times negative 16, and I still would have gotten positive 16. So when dealing with a positive result from our multiplication, our numbers can either be two positive numbers or two negative numbers. We know which pair of signs to pick by looking at B. Since B is positive 10, that means we're going to be using the two positive signs. Let's go ahead and write the factors of 16. We've got 1 and 16, 2 and 8, 4 and 4. We know that both of these are positive from what we just found. So if I were to add them together, 1 plus 16 would give me 17. 2 plus 8 is 10. And 4 plus 4 is 8. The goal is to have the middle term B, which was 10. And so we have 2 plus 8, which gave me B of 10. So now that we've found the two factors that we need, we're going to bring the leading coefficient, which is 1, or A, and we're going to split the x's. Into our sets of parentheses, and the missing pieces of this are what we just found, the plus 2 and the plus 8. The last step is to divide out anything that they have in common. So between 1 and 2, the only thing I have in common is 1, and between 1 and 8, I only have a 1 in common. So we can just write this as x plus 2 times x plus 8. Let's go ahead and try another one. 5x cubed minus 20x squared minus 35x. First things first is GCF. Do I have a greatest common factor that I can pull out? So I can pull a 5 out of all three terms, and I can also pull out an x. And so when I do that, what I end up with is x squared minus 4x minus 7. We want to factor the x squared minus 4x minus 7 piece. We will just copy and paste the 5x down the line. So the a is 1, b is -4, and c is -7. So we do a times c, which is 1 times -7, and that gives me -7. The only way to get a negative number with multiplication is to have one positive and one negative number. Well, the only factors of 7 are 1 and 7. The goal is to get to -4. So because b is negative, that means that the bigger number of our factors would be negative and the smaller would be positive. But this gives me -6, which I cannot make this -4. So because I can't get to -4, that means that 5x times x squared minus 4x minus 7 is the final factored version of the original polynomial. Let's try example number 3. 2n squared minus 38n plus 80. First things first is GCF. What can I pull out of all three terms? I can pull a 2 out. And what I have left over is n squared minus 19n plus 40. And so a is 1, b is -19, and c is 40. So a times c is 1 times 40, which is 40. We got a positive number, which means I could have 2 positive or 2 negative, but because b is negative, that means I'll be using the 2 negative numbers. The factors of 40 are 1 and 40, 2 and 20, 4 and 10, 5 and 8. We know they both have to be negative, and the goal is to get to -19. So do any of these give me -19? The first one would give me -41, the second one is -22, the third is -14, and the last one is -13. So because none of these got me to -19, that means that the final factor version is 2 times n squared minus 19n plus 40. We call n squared minus 19n plus 40 a prime polynomial, which just means that it can't be factored any further. Let's try another one. We've got 2x squared plus 11x plus 15. Do I have a GCF that I can take out? In this case, no. So we're going to go right to the Berry method. In this case, A is 2, B is 11, and C is 15. So A times C is 2 times 15, which is 30. We have those two choices of 2 positives or 2 negatives, but we know it's 2 positives because B is positive 11. The factors of 30 are 1 and 30, 2 and 15, 3 and 10, 5 and 6. So which combo is going to get me to B, which is 11? The last one will. This gets me to 11, and so that means we need to use positive 5 and positive 6. So we set up our sets of parentheses. We bring down the leading coefficient, which is 2, into both sets, and we split the x's. And then the missing pieces is what we just found. So plus 5 and plus 6. This is the important step. We have to divide out whatever they have in common. So between 2 and 5, they only have a 1 in common, but between 2 and 6, they have a 2 in common. So the first one is going to stay exactly the same, but the second one has now turned into x plus 3. And that is your final answer. The box below just gives helpful tips on figuring out the sign patterns. So if the constant term has a positive sign, that means we have the same sign. And if the middle term is positive, then they're both positive. If the middle term is negative, they're both negative. If the constant has a negative sign, that means we will have one positive and one negative. Let's go ahead and do another one. 16x squared plus 24xy plus 9y squared. We want to factor this. Do we have a GCF that we can take out? We do not. So we're going to go straight and find A, B, and C. So A is 16, B is 24, and C is 9. And so A times C is 16 times 9, which is 144. Because it's positive, we have our two choices, but we know it's two positive signs because B is positive 24. We have to write down all the factors of 144. So that's 1 and 144. That's 2 and 72. That's 3 and 48. That's 4 and 36. Six and 24. Eight and 18. 9 and 16. And 12 and 12. Now, because this is two positives, which combo is going to get me to 24, which was B? The 12 and the 12 will get me to the positive 24 that I'm looking for. So the first thing we do is we set up our parentheses. We are going to put the 16 into both, and we split our x's. We want to make sure that we put down the two factors we found, which was 12 and 12, but we're missing one thing here. In the original equation, we had x and y. We already took care of the x's up front, so we want to make sure that we add y's to the back, so that if we were to FOIL this out, we would get the y squared as that last term. Next step is to divide out whatever they have in common. Well, 16 and 12 both have a 4 in common, and it's the same thing for the second set of parentheses. So we end up with 4x plus 3y times 4x plus 3y. But we can simplify this because it's just the same thing written twice. And so we can just put 4x plus 3y squared. If we have the same binomial twice, that is called a perfect square trinomial. The last thing we're going to look at for this section is factoring by substitution. This seems to throw a lot of students off, but this just allows us to solve a complicated looking polynomial into a simpler trinomial in disguise, and then we can solve it and back substitute. So whatever the complicated part of the polynomial that's given to you is what you want to let u be equal to. So in this case, the a plus 3 is really what makes this entire thing complicated. So I'm going to let u be a plus 3. So that means wherever I see a plus 3, I'm going to put a u in for the time being. So you have 2u squared minus 5u minus 7. Now this is something we know how to factor. We don't have a greatest common factor to take out, and so a is 2, b is negative 5, and c is negative 7. So a times c is 2 times negative 7, which gives me negative 14. And with negatives, we have to have one positive and one negative number. The factors of 14 are 1 and 14 and 2 and 7. And because b is a negative 5, that means that the bigger factor is negative and the smaller is positive. So which combo is going to get me to negative 5? This last one is. So remember, we bring down the 2. In this case, we're going to split the u, and then we put in the two factors we just found. The next thing we want to do is we're going to divide out whatever they have in common. The first one has a 2 in common, and the second one only has a 1. So we end up with u plus 1 and 2u minus 7. Now this looks pretty nice, but I didn't have u in the original equation. I had a. So what we're going to do now is we are going to back substitute. Anywhere we see u, we are now going to put a plus 3. So we end up getting a plus 3 plus 1 and 2 times a plus 3 minus 7. And we just want to simplify this. The first one can be simplified pretty easy. We end up getting a plus 4, and we want to distribute the 2 in the second binomial. And so we end up getting 2a plus 6 minus 7. And so my final answer is a plus 4 times 2a minus 1. So we use substitution as a band-aid so that we can solve something that looks very complicated, and then once we're done solving the less complicated polynomial, we can just plug back in the original variable and solve for what it's actually looking for. And the last one. This is going to be a very common substitution problem. I have 5x to the 4th plus 29x squared minus 42. So what makes this complicated is the fact that this is an x squared and not an x, and this is an x to the 4th and not an x squared, which is what we would know how to solve. So in general, just as a tip here, you can just let u be whatever this middle variable is, which in this case is x squared. Let's just say I wanted to square u. Well, that's just x squared squared, and we know that a power raised to a power means we multiply them together, and I would get x to the 4th. So what that means is anywhere I see an x to the 4th, I will plug in u squared, and wherever I see an x squared, I'm going to plug in u. So I'm just going to rewrite this. That's 5u squared plus 29u minus 42. We want to see if there's a GCF. There isn't because 29 is prime. So we know that A is 5, B is 29, and C is negative 42. So A times C is 5 times negative 42, which is negative 210. Because it's negative, that means we have to have one positive and one negative number. And we need to find all the factors of 210. So we have 1 and 210. We have 2 and 105. We've got 3 and 70. We have 5 and 42. We have 6 and 35. We have 7 and 30. 10 and 21. 14 and 15. And that's it. So the goal is to get to a positive 29. Because we have a positive number, that means that the bigger number is positive and the smaller one is negative. Now, which combo is going to get me to positive 29? Negative 6 plus 35 would give me 29. So remember, we pull that leading coefficient down into both, and we're going to split our u's. So we have 5u minus 6 and 5u plus 35. We need to divide out whatever they have in common. In the first one, we only have a 1 in common, but in the second one, we have 5 in common. So we end up with 5u minus 6 and u plus 7. But we weren't looking for u in the original equation. We were looking for x. And so that means we need to back substitute, just like we did in the last problem. Wherever we see a u, we are going to plug in x squared. So we have 5x squared minus 6, and we're going to have x squared plus 7. And that's your final answer.